Hey there, welcome to a Dylan Does tutorial. I'm working with war probabilities, essentially how much productivity a baseball player is going to have in a given season based on minor league data. And specifically, that minor league data is rank. So I want to show you this model I've been working on. I'm just going to delete this real quick. We're going to create this model using probabilities of their minor league statistics. Well, actually, not minor league statistics. This time, we're only going to use their prospect rank. So I have this data here. Brandon Wood in 2006 was a third-ranked prospect, and we want to find out what a third-ranked prospect has, or whether it has an effect on their WAR probability. So Brandon Wood actually failed. I don't think he was very good, but we'll find out, given this data of over the years, what kind of probabilities rank has on success in the MLB. So let's get started. I'm going to create a WAR probability variable as a general linear model where WAR 8, essentially the amount of the amount of WAR or if the amount of WAR is 8 or greater, which is a binomial variable, as a regression on rank. And we're going to use this data, which I have called minor league bats. And it's important that since this is binomial variables that we're measuring, we specify this with binomial. So we'll go ahead and run this. It would appear I've forgotten a comma. And there we go. Alright, so we have this WAR probability value right here. So let's get a summary of this data using the summary function. So if you look, the rank is statistically significant at the 99 percentile. So there is a pretty good effect, or we would think that there is a pretty good effect that rank has a measure of success, or rank has an effect on success in the MLB. Now, specifically, rank itself isn't anything; it's just a quantifier that someone gave because their statistics were good. But for our purposes, given the data, rank should be useful for selecting prospects who will be good in the future. But we have to make sure this data is good, so let's do a couple things. As you can see here, this is essentially our T statistic based around the 0 point, and it is fairly significant. But let's run a chi-squared at the 95 percentile on 181 degrees of freedom. Chi-squared. So we get this value of 212, and since it's greater than the number of freedoms or degrees of freedom we have, we can reject the null hypothesis. So we can believe that this model is a fairly good model and accurate. But this data, if we look at it, what does the coefficient actually mean? A coefficient of with a beta 1 of negative 0.02 is really kind of hard to interpret because it's a probability regression model. It's essentially the log of the odds will decrease by 0.02 So the war will decrease by the log of the odds of 0.02, and that doesn't really make sense. It's kind of a hard concept to grasp, but it's easier if you convert this into a exponential, essentially just make it the percentage change in the odds. So we can do this by simply just typing in our beta coefficient, which is 0.02, 5792. I'll run this. So essentially, as your rank decreases, your probability increases by 0.97% each time. So let's go ahead and see what this data actually looks like by plotting it. We're going to plot miner bats rank, the fitted values of the war probability, and I'm going to add a couple titles and axes. I'm going to make this probabilities of, actually we'll make it war probabilities. I'm going to create a subtitle. This will be looking 5 years out. I'll make it capital, why not? And then we need an axis label for the x-axis. This is going to be rank. I'll make a y-axis label. And this will be probability. And barring any catastrophic typos, we should have a decent plot. I'm going to clear this. Unexpected symbol, of course. And I'm not sure why. Unexpected symbol. Did I spell war probability right? I'm just going to pause this real quickly while okay, the code is debugged, so let's go ahead and run this. Now we have this beautiful looking graph, and we want the war probabilities for the probability and the rank. So given a rank, say for instance 1, there's a probability that looks like about above 0.4 if you're rank number 1 of having war in 5 years greater than 8. For as well, I'm going to go to all the values. 20, it looks like it's about 0.35. We're not totally sure what it is, so what we want to do is we're going to create this predict variable. We're just going to predict all the fitted values. So I'm going to create a new data frame, which is fits. So equal the fitted value of the war probabilities where the rank is equal to miner bats. $rank. And that has run. So now we just need to order these from least to greatest. So using the order, we're going to order predict $fits, which is going to be here. So there's our fits. So if you look at this data, it's now ordered it from 1 to 0 or 1 to 100. If you are the #1 prospect for the year, you have a 48% probability that you will have a WAR of greater than 8 within 5 years. If you are the 20th ranked, as we had looked, you have a predicted probability of having a 0.36% or a 0.36 chance or 36% chance that you'll have a WAR or a career WAR of greater than 8 within 5 years. So, well, thank you for watching how to do a probability regression, and come back for more. Thanks.